everybody, Dawson here, and I am here to teach you about systems of equations elimination method. So there's, if you've watched the graphing one, there are several different types of solution methods to solving systems of equations, and we're going to look at elimination today. But they're all basically trying to do the same thing. You're given two equations, and you need to find out a point, one coordinate point, one x and one y, that will be a solution to both of the equations. And with graphing, if you watch that video, you basically graph the two lines, and you look for the point where they cross, and that's where you have the same solution for both lines, and that's great. But sometimes the people that give you the equations, they don't give it to you in nice, easy slope-intercept form. Sometimes you get it in standard form, just like we have here. And so that's not very nice, because that's going to make it a lot harder for us to work with in terms of graphing. So there's another way to solve this problem. With this type of problem, what we can do instead of graphing it is we can eliminate, it's kind of weird, eliminate one of the variables and then solve for the other variable. And let me kind of walk you through this. This can get a little bit weird because it doesn't seem like something we would normally do, but it works. Somebody figured it out. I don't know who. They must be very smart, certainly smarter than I. So let's look at how we're going to go about solving this. If I pretend that this is basically a big math problem, a big addition problem, so I got, like standard 2 plus 2 kind of thing. And we have our following rules. We know we can only combine our x's, we can only combine our y's, we can only combine our whole numbers. And nicely, standard notation puts everything together in a nice, neat row for us. So that works great. And so if I put these two together, if I say negative 4x plus 4x, I'm going to get 0 x's. All right, there. Okay, so just follow along with me. I'm just going right down. Now I have negative 2y's plus 8y's. That's going to give me positive 6y. And I have negative 12 minus 24, and that will give me a negative 36. Okay. Now 0x is just 0 because anything times 0 is 0, so I can just basically not even have to worry about writing that thing down. I just get rid of that whole deal there. And I'm left with 6y equals negative 36. So, anyway, so this is a one-step equation. I can do this, divide both sides by 6, and I get the fact that y equals negative 6. Now, this is important because y equals negative 6. That negative 6 is part of that solution. So my coordinate point, or my solution to this problem, will include a negative 6. So that's an important piece. I know that. Now I have to figure out what the x part of this equation is. So what do I do from here? Well, I've got a big equation up here. I've got 2, in fact, and I have a y equals negative 6. If I plug negative 6 back into either one of these two equations, I will get the x value. That will be this part. So let's do that. Let's just take one of them. Doesn't matter which one. I'll take the top one because that has a smaller number for me to multiply, and I'm always struggle with my multiplication, so I am just going to keep this as easy as possible. So I'm copying the equation, negative 4x minus 2, but instead of y, I'm going to substitute in negative 6, and that equals negative 12. Okay, I basically am just going to go through what I always do to solve an equation. I'm going to simplify as much as I can and get it down. You will notice once I do this multiplication, negative 2 times negative 6, I get a positive 12. I am now at a situation where I am doing a two-step equation, just a standard two-step equation that we have done 400,000 times. Be careful on this one. Everybody wants to make this 0. It's not. Negative 12 minus 12 is a negative 24, so just be careful of that. And then negative 4x, because this part will cancel out. All right, do my second part of my two-step equation, and I get the fact that x equals a positive, because a negative divided by a negative is a positive 6. All right, 24 divided by 4 is 6. So that's my x value. Plug it up here. Boom. That is the point at which those two will cross each other. So it's a nice little technique. Otherwise, I have to rewrite both of these equations into slope-intercept form, then graph it. And hey, what if I didn't have a piece of graph paper? I wouldn't be able to solve it. So, all right, so that's nice. It's really nice when one of them is positive and one of them is negative. And when you do this, it's just going to cancel out right away. But that's not always the case, of course. Sometimes you look at this equation here, and while they're in standard notation, they're not going to cancel out nicely. So I have to do one additional step. I have to pick one of the two equations, because I know this is y and this is y, so that'll be easy to cancel out if only one was negative. But I can change the sign of this y. I can make it a negative if I want to, but if I make that negative, I have to change the sign of everything in the equation. So if this is negative, it becomes positive. If this is negative, it becomes positive. Now I've changed the sign of every single one in my equation. Now when I add these two together, they are going to cancel out, which is exactly what I want. So I'm left with 8x plus 3x, and that gives me 11x. And I have negative 16 plus 5. That gives me negative 11. And look at these numbers. They just work out so nicely. Solve for my x. X equals negative 1. So that magic coordinate point, I know that's out there. Negative 1 is my x portion of it. See, I solved for x this time instead of y. And so I know my x. And I'm going to do the same thing I did last time. If I know that x is negative 1, I'm going to plug it back into one of my two equations. And let's plug it into 8x. Doesn't matter which equation you choose. You can do either one. 8x. And in this case, instead of, not 8x. 8 times, so you got to be careful. Sometimes you're going too fast, you make mistakes. 8 times whatever x is. And in this case, it's negative 1. And that's going to be plus y equals negative 16. I multiply these two out. I get negative 8 plus y equals negative 16. Add 8 to both sides. And I get the fact that y equals negative 8. And so that is my y value for that solution. So once again, here is my solution. Negative 1 comma negative 8. And I have just found the coordinate point that will work for both of these equations. It's a pretty cool system that it works like that. Let me show you one more, because sometimes they're in standard form, but this is not good. I mean, basically, if I change it just to a positive or negative, nothing gets rid of each other. It's a mess. But instead of just multiplying by negative, what I can do is I can multiply by a negative 3 on the top. Because if I multiply by negative 3, this y by negative 3, I'm going to end up with a negative 3y and a positive 3y, and those will cancel out then. So I'm going to multiply this whole equation by negative 3, like that. So I'm going to rewrite it over here. That's positive, because negative 3 times 7 times negative 7 is going to be positive 21x minus 3y equals a positive, because it's a negative times a negative. And here you have 3 times 9, which is 27. 27, so I know my 7 is in the ones place. And then 3 times 1, that's 30, plus that 20, and I'm going to get 57. So positive 57. So this is my rewritten equation for this one. And now I just write this equation below the first one. So negative 2x plus 3y equals negative 19. Do my same addition piece that I've always been doing. 21x minus 2x, that's a 19x. And then this is going to cancel out, so I don't have to worry about that. And that equals, I take the 9 from the 7, I need to borrow, so that makes it 17. And that's going to give me 8 on this side. But this was a 4, I take the 1, and I'm left with 38. Okay, now divide both sides by 19 to get x all by itself. And it works out again very nicely that these happen to go in evenly 2 times. 38 divided by 19 is 2. So that's my x-coordinate for this. I'm going to put 2 in there for my x. I don't know what my y is yet. But let's just do what we always do. We plug this into our equation and solve for it. I'm going to plug it into the original top equation over here. So negative 7x, well, I did it again. Not negative 7x, it's negative 7 times whatever x is. And in this case, we know what it is. It's 2. And that's a plus y equals negative 19. So negative 7 times 2 is negative 14 plus y equals negative 19. Add 14 to both sides of the equation. And I'm left with y equals negative 5. And there is my other coordinate, or my other value for my coordinate point. 2 comma negative 5, and those are that's my answer for this solution. So that's graphing inequalities. I didn't change the title on this. Sorry about that. This is systems of equations elimination method. So systems of equations elimination method. And yeah, hope you learned some stuff. And if you have questions, rewatch it again a couple times, and then come on in and ask me for help. Take care. Have a good one.